Good day, my name is Jonathan Diaz Marin, and this video corresponds to the task 4 of the computer architecture course. Uh, the purpose of the practical activity is to show the configuration of Visual Studio Code with maths and TANS station and the execution of 5 programs developed in assembly language. During the video, I will show a basic calculator as an ascending counter from 1 to 10 and decimal to binary converter, the sum of the first natural numbers, and a customization test program with my personal information. First, I configure Visual Studio Code as the development environment. Visual Studio Code is not the program language. It is the editor where I write the executed the assembly code. For this activity, I installed an extension compatible with maths and tags, which allows me to create the fields with the ANS extension and run the programs directly from the editor. Each program was saved with the ANS extension, usernames without space to avoid execution errors. The first program is a basic calculator. I ask the user to enter two numbers and add the arithmetic operation. The program supports addition, subtraction, multiplication, and division. The numbers entered from the keyboard are initially read as ASCII charters. So the program subtract 30 had 13 hexadecimal to convert them into real numeric values. After performing the select operation, the result is displayed on the screen using DOA's interrupt 21H. Uh, the second program is an ascending counter from 1 to 10. In this program, I used a loop structure to print the numbers sequentially. The register CAs is used to control the number of repetition, and the program prints each value on the screen. This exercise demonstrates how loops and registers can be used in assembly language to repeat instructions. The third program converts a decimal number into binary number. If the user enter a decimal number from 0 to 9, and the program evaluates each bit to display its binary representation. This program helps to demonstrate how binary values are, are handled and allow lived inside the computer architecture. The for program calculates the sum of the first natural numbers. The user enters the value of the number natural and the program adds the number from 1 to using a loop for example. For example, if the user entered the number 7, the program calculates 7, 1 plus, 2 plus, 3 plus, 4 plus, 5 plus, 6 plus, 7 plus, and the result is 28. This program shows the use of the loops, accumulators, and conditional joins in assembly language. The file program displays a customized text message with my file name, an academic program, and the university. This program uses interroot 21H with function 09H to display text strings on the screen. I also added decorative lines to give the output a more organized and personalized design. All the programs follow the basic structure of assembly program. The model section defines the memory model to stat sections, reserve memory for the stat. The data sections contains the variables and message uses by the program. Finally, the code section contains the instructions that are executed by the processor. The instructions move is used to move that data between registers and variables. The instructions in 21H is used to call DOS service, such as reading keyboard input, printing shaders, printing strings, and ending the program. During the development of this activity, I used generative artificial intelligence as an academic support tool. The AI helped me understand the structure of assembly programs, identify errors in the code, improve commands, and clarify the use of the instruction such as mob, up, sub, loop, and even 21H. However, I reviewed and tested each program manually in Visual Studio Code to verify that the code worked correctly and produced the expected results. This practical activity allowed me to understand the basic operation of assembly language and its relationship with computer architecture. Through these five programs, I practice the use of registers, memory segments, loops, arithmetic operations, ATC conversion, and DOA's interroots. Thank you very much.